Welcome to 5.5, side, 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 and hypotenuse leg. And what we want to understand here is if you have all three sides of one triangle congruent to all three sides of another triangle, then both triangles are congruent to each other. And hypotenuse leg says if you have a right triangle, and it has to be a right triangle, and that you have a hypotenuse of one and a hypotenuse of the other, and you have one of the legs, then you have two triangles that are congruent to each other. That's called hypotenuse leg, but they have to be right triangles. Okay, is there enough information here? So these are not right triangles, and we do have, what we need to look at here is the order that they're going to give it to you. A is to D, so, or excuse me, AB is to DB. AB is to DB, okay, those are marked correctly, all right, and then BC is to BE, so BC is to BE, and those are marked correctly to each other. And then therefore, A and C and D and E. A, C, and D and E. Those are marked correctly. So they're in the correct order. That's what you have to look for, the correct order. They're going to appear to be correct, but if the order is wrong, you cannot say it. So watch for that. So yes, there is enough information for side, side, side. All right, so now you have a right triangle. So it looks like we have hypotenuse leg. So let's make sure it's all right. We see AC here. So A to C should match F to D. F to D, yes, that's both hypotenuse. And the leg AB should be with FE. And it is. All right, so yes, there's enough information here for hypotenuse leg. All right. So whether the congruent statement is true. So RST and TQP. So let's check and make sure. So far, we think it's side, side, side. All right. So let's check it. RS, okay, there's RS, should be the same as TQ. And that's not. So we say, no, it's not in the correct order. RS should be with, since it says it's 2 hash marks, this has 1. So that is definitely not the correct order, okay? So if the order's wrong, do not say that they're congruent. Now, we can argue whether or not the two triangles are congruent. That's not what you're learning. So the order has to be correct, so make sure you check it. All right, now, proof. Let's go ahead and get started. So we have the given. I'm not going to write the given. We have all those things here for the given. And the proof statement goes down here, all right? Triangle LMJ is congruent to triangle JKL. All right. I'm just going to go ahead and make it look nicer. All right. Triangle LMJ is congruent to triangle JKL. All right. That's your proof statement. All right. So let's make sure everything's marked. LM is congruent to JK. Okay. Those are marked right here and right here. MJ is marked to KL. Okay. Now, let's just look at the order LMJ. LMJ. So the single hash mark to double hash mark goes with JKL. JKL. All right, single to double. All right, so it's in the correct order. Now, what I'm going to say now is, what else can we say about this? Well, you should be able to say that JL is congruent to JL or LJ. And why? That's reflexive property. And therefore, we can say that triangle MJ is congruent to triangle JKL, side, side, side. The third side is congruent to itself. All right. Stability means every single picture is a triangle. There's a triangle, there's a triangle, there's a triangle. So every opening, I should say, is a triangle. So you're looking at the openings here. Those are all triangles. So yes, it's stable. So if you had something like this, again, we'll do, there's a triangle, there's a triangle, but this right here is not a triangle. So that would not be a stable picture. All right, another proof. We have our givens, And we're trying to say that triangle BAD is congruent with triangle CDA. So let's check that order real quickly. BA is right here, and CD is here, and AD is there, and DA is here, and then BD. BD is the long line, and CA is the long line. Okay, so it appears to be right. All right, now let's mark everything they tell us right here, all of the given. Let's go ahead and mark it AC. Now we're going to redraw these. It does say to redraw them. So I'm going to redraw AC. So A, C, and D here. And then I'm going to put, B to D is the long one, and A is right here. I'm going to redraw these like this. I just separated the two triangles here. So it says AC is congruent to BD, and AB is perpendicular to AD, perpendicular. So first of all, triangle BAD and triangle BAD and triangle CDA are right triangles. Definition of perpendicular lines. So that makes them 90 degrees, so those are both right triangles, all right, after our givens there. And that's all we have so far. So, but in the original picture, AD is reflexive. In our picture down here, AD is not reflexive. So we're going to say that AD is congruent to DA, and that's reflexive, congruent to itself. And then you can say those two triangles are congruent because of hypotenuse leg theorem. Describe and correct the error in identifying the congruent triangles. All right, it says side, side, side. Well, it appears that they're side, side, side. So let's check the order. TU goes with XY. And again, that's a double hash mark, that's a single hash mark, so no. But write it in the correct order. Okay, let's do the correct order. So I'm going to erase all of that. And let's write the correct order. Triangle, we'll say TUV, that's a single, double, and then triple, is congruent to, where's the single? And then doubles afterwards. So we're going to go ZYX, triangle ZY, and then X, and that gets us to the triple side. So it went single, double, triple. So that's how you figure those out. And then you could say by side, side, side. So you have to get the order correct. All right, so we have at least a rectangle here. We have four right angles. The distances between consecutive bases on a softball field are the same. All right, so if the distances are the same, then we have a square. The distance from home plate to second base is the same as the distance from first base to third base. So this is the same as this. All right. The angles created at each base are 90 degrees. Prove that triangle H, let's see, where is it at? H is home plate, first base is F, and S is second base, triangle HS. All right, so we're going to draw this out here. H, F, S, home plate, first base, second base, is congruent to triangle FST, first base, second base, third base. First base, second base, third base. Okay, so that one's this one. I try to draw these nice and neat. Okay, so that's first base, second base, and third base here. Well, let's put those in the right order here. first base, second base, and third base. And then the final one, second base, third base, and home plate. So we have the left side of the triangle there. So that's second base, third base, and home plate. Yeah, so I separated all the triangles here, and there's certain things that we know. So the distances of the legs are the same. You also have a 90-degree angle there at each plate. All right. Now, prove that the three triangles are congruent to each other. Well, it's pretty easy to prove that with side angle side. We had side angle side before, so we could just say that those three triangles are congruent because of side angle side. Pretty simple. All right. To support a tree, you attach wires from the trunk. Okay, to support a tree, you attach wires from the trunk of the tree to stakes in the ground, as shown in the diagram. Okay. What additional information do you need to use the hypotenuse leg congruence theorem to prove that the triangles are congruent? All right. Well, you have to know that JL, the hypotenuses, are congruent to LM. You'd have to know that. And then suppose K is the midpoint, and by definition a midpoint, you have JK congruent to KM by definition of midpoint. So then you name a theorem that you can prove for part B. If you have those two and you have the hypotenuses, then it's the hypotenuse leg theorem. So they're just asking that you reiterate what you've learned. All right, so now we're graphing. -2, -2 is A. 4, -2 is B. And C is at 4, 6. Okay, so there's A, B, C. D is at 5, 7. And that's D. 5, 1 is E. And 13, 1 is F. Let's just say this is C here. Okay, so there's our two triangles. Are they congruent? Well, we can count A, B, 1, 2, 3, 4, 5, 6, and B to C, 1, 2, 3, 4, 5, 6, 7, 8, D to E, 1, 2, 3, 4, 5, 6, and E to F, 1, 2, 3, 4, 5, 6, 7, 8. All right, and this is a right triangle. And now check our order, A, B, C, A, B, C, and then we go D, E, F, D, E, and F. And 6 to 8, 6 to 8, 6 to 8, 6 to 8. It is in the correct order, and so you have side angle side. Yes, they are congruent, side angle side. All right. Are AC and DF parallel? Well, if they were, we could say that angle B is 139 degrees from the consecutive interior angles, but you can't say that. But with vertical angles, you can say that B is 139 degrees. So vertical angles, that is a true thing to say. So therefore, they are congruent, or excuse me, they are parallel because of the consecutive interior angles converse theorem. They make 180 degrees. Now graphing, inequalities, so we're shading with inequalities. So we're going to rewrite this as y is less than or equal to. I'm going to put the negative x first and the plus 4 second so that it's in slope-intercept form. The slope is -1 over +1, and my intercept is at 4. 1, 2, 3, 4. So I go down 1 over 1, down 1 over 1, down 1 over 1. Since I have an equal sign, this is going to be a solid line. If there was no equal sign, you'd have to do dotted. And then less than means we shade below the line. And that's how you shade those. And then there's all the answers you can take a look at. And you're done.